Hi there everyone, Ashley this side. Welcome to my ultimate video of Docker where we'll learn about Docker from scratch in just one video. And at the end of the video we will learn how to run, pull and run Docker images that will not be present in our local system. So let's start the amazing journey of Docker. Okay, first we'll discuss about the agenda, what we'll learn today. So first, we will learn about what is Docker, then we'll discuss about virtual machine versus containers, and then we get moved to the architecture of Docker. Okay, let's start. So, what is Docker and why everyone is using in these days? So, a Docker is a platform for building, running, and shipping application in a consistent manner. So, if your application works on your development machine, it can run and function the same way on other machine. So if you have been developing software for a while, you have been probably come across the situation where your application works on your development machine but does not somewhere else. So there are three reasons why this happen. Well, this can happen if one or more files are not included as a part of your deployment. So your application is not completely deployed. It's missing something. This can also happen if the target machine is running a different version of some software that your application needs. Let's say our application needs Node version 14, but the target machine is running Node version 9. This can also happen if the configuration settings like environment variable are different across these machines. And this is where Docker comes to the rescue. With Docker, we can easily package up our application with everything it's need as run it anywhere or any machine. With Docker, so if your application needs a given version of Node and MongoDB, all of these will be included in your application package. Now you can take this package and run it on any machine that run Docker. So if it if it's work on your development machine, it's definitely going to work on your test and production machine. Now there's more. If someone joins your team, they do not have to spend half a day or setting up a new machine to run your application. They don't have to install and configure all these dependencies. They simply tell Docker to bring up your application, and Docker itself will automatically download and run these dependencies inside an isolated environment called a container. And this is the beauty of Docker. This isolated environment allows multiple applications use different version of some software side by side. So one application may use Node version 14, another version may use Node version 9. Both these applications can run side by side on the same machine without messing with each other. So this is how Docker allows to consistently run an application on the different machine. One more benefits here. When we are done with the when we are done with this application and don't want to work on it anymore, we can remove the application and all its dependencies in one go. Without Docker, as we work on different projects, our development machine gets clustered with so many libraries and tools that are used by different applications, and then after a while we don't know if we can remove one or more of these tools because we are always afraid we would mess up with some application. With Docker, we don't have to worry about this because each application run with its dependencies inside an isolated environment. We can safely remove an application with all its dependencies to clear up our machine. So in a nutshell, Docker helps us consistently build, run, and ship our application. Now let's discuss about containers and virtual machine. A container is an isolated environment for running an application. Now, one of the questions that often comes up is how are containers different from virtual machine or VMS? Well, a virtual machine, as the name implies, is an abstraction of a machine or physical hardware, so we can run several virtual machines on a real physical machine. For example, we can have a Mac on this machine. We can run two virtual machines, one running Windows and another running Linux. How do we do that? Using a tool called Hypervisor. So, Hypervisor is a software that we use to create and manage virtual machine. There are many hypervisors available out there, like VirtualBox and VMwares, which are cross-platform, so they can run on Windows, Mac, Mac OS, Linux, and Hyper-V, which is only for Windows. So, with a hypervisor, we can manage virtual machine. Now, what is the benefit of building virtual machine? For us software developers, we can run an application in isolation inside a virtual machine. So, on the same physical machine, we can have two different virtual machines, each running a complete different application, and each application have a exact dependencies it needs. So, application 1 use Node version 14, MongoDB version 4, while application 2 use Node version 9 and MongoDB version 3. All these are running in same machine but in different isolated environments. That's on of the benefits of virtual machine, but there are a number of problems with the model. Each virtual machine needs full copy of OS that needs to be licensed, patched and monitored, and that's why these virtual machines are slow to start because the entire operating system has to be loaded just like starting your computer. Another problem is that these virtual machines are resource intensive because each virtual machine takes a slice of the actual physical hardware resources like CPU, memory, and desktop. So, if you have a 8 gigabyte memory, that memory has to be divided between different virtual machines. Of course, we can decide that how much memory to allocate to each virtual machine, but at the end of the day, we have limit in terms of the number of virtual machines we can run on a machine. Usually a handful, otherwise we are going to run out of hardware resources. So let's talk about the containers. Container give us some kind of isolation, so we can run multiple application in isolation, but they are more lightweight. They don't need a full operating system. In fact, all container on a single machine share the operating system of the host. So that means we need to license, patch, and monitor a single operating system. Also, because the operating system has the already started on the host, a container can start up pretty quickly, usually in a second, sometime less. And also, these containers don't need a slice of a hardware resources on the host. So we don't need to give them a specified number of CPU, core, or slice of memory or disk space. So on a single host, we can run tens or even hundred of containers side by side. So these are the difference between container and a virtual machine. Now let's talk about Docker architecture. So for understanding how it's work, Docker use a client server architecture. So it has a client component that takes to a server component that talks to a server component using a RESTful API. The server, also called a Docker engine, sits on the background and, and takes care of building and running Docker containers. But technically a container is just a process like other processes running on your computer, but it's a special kind of process. Now, as I told you, Unlike virtual machine, containers don't contain a full-blown operating system. Instead, all containers on a host share a operating system of the host. Now, more accurately, all these containers share the kernel of the host. What's the kernel? The kernel is the core of the operating system. It's just like a engine of the car. It's the part that manages all the application as well as hardware resources like memory and CPU. Every operating system has its own kernel or engine, and these kernel have different API that we cannot run a window application on Linux because under the hood, this application needs to talk to the kernel of the underlying operating system. So that's mean on a Linux machine, we can only run Linux container because this container needs Linux on a window machine. However, we can run both Windows and Linux container because Windows 10 and 11 shipping with custom built Linux kernel. This is addition to the window and kernel that's always been in window. It's not a replacement. So with this Linux kernel, now we can run Linux application natively and window. So on window, we will run both Linux and window container. Our window containers share the Windows kernel and our Linux containers share the Linux kernel. Now, what about Mac OS? Well, Mac OS has its own kernel, which is different from Linux and Windows kernel, and this kernel does not have the native support for continuous application. So, Docker on Mac uses a lightweight Linux virtual machine to run Linux container. That's all about architecture. Docker installation. So, if you have been seen my last video, you can easily set up your Docker in your local system. Now, what is Docker images? So we create a Docker file that will create a Docker image and run Docker images to create a Docker containers. So images are the template of projects and containers are running instances of images. So just like Java and C++, we have a class and the instances of the class. Same like that, here the images and the containers are the instances of the images. So images is a kind of ready to use software read-only templates, images made with source code, libraries, external dependencies, and tool. Images cannot be updated. If you want to make changes in images, you have to create a new one. Okay, now we will go to the CMD and try to pull some images from the internet. So now we'll learn how to run Docker images. So first we'll check the version of Docker. So Docker hyphen version. So we have a latest version of Docker 25.0.3 and now we'll run the Docker images. That is the command is Docker run hello world. So this is not present locally in our system. Yeah, so it's download from the internet. So you can see this message. Download new image from for Hello World latest. Uh, Now we can check how many images running currently in our system. So there's a command docker images. So currently only one image is present in our system. Hello world tag is latest. This is the image ID and this created 11 minutes ago. Someone created this image 11 minutes ago and posted it on the internet. So we just pulling this image from the internet and the size of this image is 13.3 KB. Next we'll uh, try to learn some more images. Try to pull try to pull some more images from the Docker Hub. So Docker is Docker Hub is a platform where um, people post or their images and we can just simply run it and use it. And in our upcoming videos, we will learn how to create uh, our own images. So just continue this series. I will just continue series. साथ रहिए और लर्न करते रहिए डॉकर के बारे में. So that's it. Thank you so much, and please subscribe my channel if you like this video and share it as well.